Out in the distant reaches of our solar system, beyond the familiar gas giants Jupiter and Saturn, lies a world that has long captivated the curiosity of scientists and dreamers alike. Uranus, a mysterious and icy giant, it remains one of the least explored planets in our cosmic neighborhood. Until now, Uranus has mostly remained an enigma, tucked away on the far side of our understanding, often overshadowed by its more well-known neighbors. But this distant planet is about to reveal its hidden secrets, secrets that may help unlock the broader mysteries of our solar system's formation and perhaps the very nature of icy planets in the galaxy. Uranus is more than just a cold, distant world. It's a living puzzle, a place where the laws of physics may behave in unexpected ways, offering a treasure trove of scientific discoveries. From its strange axial tilt to its thin and elusive rings, Uranus has earned its place as one of the solar system's most intriguing planets. The time has come to bring this cold, distant world into the light. There is something hypnotic about Uranus' striking blue-green hue. Unlike any other planet in our solar system, its color comes from the methane gas in its upper atmosphere, which absorbs red light and reflects the cooler blue and green wavelengths. The result is a planet that appears to glow with an ethereal, icy light, a chilling beauty suspended in the darkness of space. But what really makes Uranus stand out is not just its color, but its extraordinary tilt. While the majority of planets in the solar system rotate more or less upright, Uranus is different. In fact, its axis is tilted at nearly 98 degrees, making it the most tilted planet in the entire solar system. Imagine a planet where the poles point directly toward the sun and the equator lies flat, rolling through space like a barrel on its side. This tilt means that Uranus experiences extreme seasons, with each of its poles facing the sun for 42 years at a time before plunging into 42 years of darkness. This bizarre tilt is a mystery in itself. How did Uranus end up on its side? Was it the result of a massive collision with another celestial body? Did an ancient impact change the planet's orientation? Or is there some other force at play here? These questions have fueled scientific debates for decades, and unlocking the answer may reveal critical insights into the dynamics of planetary formation in the early solar system. As we delve deeper into Uranus, we enter the frigid, turbulent realm of its atmosphere, a place where winds whip at speeds of over 900 kilometers per hour and the temperature plummets to a bone-chilling minus 224 degrees Celsius. This makes Uranus one of the coldest planets in the solar system, even colder than Neptune, despite being further from the Sun. In fact, Uranus radiates more heat than it receives from the Sun, a puzzle that has perplexed astronomers for years. What's generating this extra warmth? The planet's atmosphere is primarily composed of hydrogen, helium, and methane, with traces of ammonia and water vapor. This icy mix gives Uranus its signature cold, stormy appearance. Despite its freezing temperatures, the planet's atmosphere is not static. Dynamic weather systems churn beneath the clouds, creating bands of clouds and massive storm systems that the surface. Unlike Jupiter, which boasts the Great Red Spot, a massive, swirling storm that has lasted for centuries, Uranus storms are more fleeting, appearing and vanishing with little predictability. One of the most intriguing features of the Uranian atmosphere is its lack of visible features when compared to the colorful cloud bands of Jupiter or Saturn. The reason for this may lie beneath the surface, in the planet's deeper layers, where atmospheric dynamics remain a subject of active study. Uranus' atmosphere is still full of secrets, and unraveling them could give us a deeper understanding of the processes at work on ice giants in general. Rings are often associated with Saturn. They're brilliant, shining bands standing out against the darkness of space. But Uranus, with its more subtle, dark rings, offers a different kind of beauty. Uranus has 13 known rings, composed primarily of small, dark particles that absorb light rather than reflecting it. These rings are faint, almost invisible to the naked eye, but when studied closely, they tell a fascinating story of planetary history. Uranus rings are believed to be young, perhaps only a few 100 million years old, and their origin remains one of the great mysteries of the solar system. Some scientists speculate that the rings may have formed from the remnants of a moon that was shattered by a collision, while others believe they could be the product of an ancient ring system that has evolved over time. The fact that Uranus rings are so much darker than those of Saturn hints at a different process in their creation, perhaps the result of interactions with nearby moons, or from collisions with other bodies in the past. These faint, dark rings also raise questions about how planetary rings form and evolve, not just around giant gas planets like Saturn, but also around smaller, icy planets like Uranus. As we continue to study them, Uranus rings may hold the key to understanding the forces that shape planetary systems. Uranus is not just a lonely planet adrift in the outer reaches of the solar system. It is surrounded by a collection of 27 known moons, each one with its own unique characteristics and mysterious features. These moons range from the icy and smooth to the dark and cratered, each holding clues to the planet's violent past. Take Miranda, for example. This small moon is perhaps the strangest in the Uranian system. Its surface is a chaotic blend of ridges, valleys, and fractures, suggesting that it may have been shattered and reassembled by some ancient cosmic event. What happened to Miranda? Was it impacted by a large object in the distant past? Or is its strange appearance the result of some ongoing process within the moon itself? Then there's Ariel, a moon that displays signs of tectonic activity beneath its icy shell. With its smooth surface and fewer craters than expected, Ariel appears to have undergone resurfacing in its past, hinting at some kind of internal heat source. And nearby Umbriel, with its dark, heavily cratered surface, seems to have remained unchanged for billions of years, making it a time capsule of sorts, preserving the early conditions of the Uranian system. Each of these moons presents a different piece of the puzzle. Together, they offer a fascinating glimpse into the processes that shaped the Uranian system, from ancient impacts to the possibility of internal oceans and the potential for life. Uranus has remained largely untouched by human hands. At over 2.7 billion kilometers from the Sun, it's one of the most distant planets from Earth, and only one spacecraft, NASA's Voyager 2, has ever passed by this icy giant. In 1986, Voyager 2 made its closest approach to Uranus, sending back crucial images and data that would lay the groundwork for future exploration. But while Voyager 2's flyby was groundbreaking, it was brief, lasting only a few hours. Since then, no spacecraft has ventured back to Uranus. However, the time for further exploration is drawing near. In the coming years, space agencies are planning missions to the outer solar system, with a potential future mission dedicated to Uranus. These missions could involve orbiters that study Uranus up close, analyzing its atmosphere, magnetic field, moons, and rings with unprecedented detail. Such missions will help answer the remaining questions about this mysterious planet. Why does Uranus radiate more heat than it receives? How did its strange tilt come about? And what secrets might its moons hold about the early days of the solar system? Uranus may seem distant and cold, but it is a world of untold potential. With each new mission and every breakthrough in technology, we move closer to understanding the full scope of this planet's mysteries. The data from Uranus moons could provide crucial information about planetary formation, icy bodies, and the processes that shape the outer regions of the solar system. Perhaps one day, Uranus will become more than just an object of scientific study. As humanity's reach into space extends further, moons like Miranda and Ariel may become targets for exploration and even colonization. The resources beneath their icy surfaces could one day play a role in humanity's future as we venture into the farthest corners of the galaxy.